Good day everyone. This video is a course requirement in our subject, which is math analysis for teachers. It is my pleasure to share with you the assigned topic that was given to me by our professor, Dr. Jess Pizarro. And this topic is all about the applications involving an absolute extremum on a closed interval. By the way, I am Kevin Viorpilla, a student of a graduate school of St. Paul University, Philippines. So we consider some problems in which the solution is an absolute extremum of a function on a closed interval. Use is a made of extreme value theorem, which assures that both an absolute maximum value and an absolute minimum value of a function exist on a closed interval if the function is continuous on that closed interval. So let's start with a graph. And let's say we have a function that has a graph like this. And let's name the points A, B, C, D, E, F. So the absolute maximum in this graph is the highest point. So this is the highest point in this graph. So that is the absolute maximum. And the absolute minimum is the lowest point in the graph. So this is the lowest point. So this is the absolute minimum. The highest peak here is not the absolute maximum, but rather it is a relative maximum. And in this part is the relative minimum. So to find for the absolute extrema of a closed interval, we are going to find for the absolute minimum and absolute maximum for all x in the interval. So let's have first a quick review before we go to its application. So let's try to determine the absolute extrema on the interval 1, 4 in the function f of x is equal to x squared minus 4x plus 9. So let's start determining the critical numbers or critical value of the given function, this function, by getting its first derivative. So what is the derivative of x squared? It's 2x. How about the derivative of negative 4x? Very good, it's negative 4. And the derivative of a constant is 0. So therefore, the derivative of this function is 2x minus 4. And let's equate this as equal to 0. In order for us to find for the value of x, we are going to transpose negative 4 into the other side. And we will have it like this. 2x is equal to 4. In order for us to leave this x here in this side, we are going to divide both sides by 2 in order for us to cancel 2 here. So therefore, the value of x now is 2. And this 2 here is called the critical value. So now we have our critical value. And to determine the absolute extrema, we need to evaluate the given function using critical value, this critical value, and the two endpoints is 1 and 4. So if our x is 2, so let's just substitute the value of x in this equation in our original equation, which is x squared minus 4x plus 9. So this will give us 5. So to check this, let's use our calculator. So yeah. So we are going to input the equation, which is x squared minus 4x plus 9, and we're just going to click calc in this part. And then this calculator is asking us on what is the value of x. So since we are trying to find the answer of this function when the value of our x is 2. So we are going to write 2 here. So 2, then press equal sign. So therefore, we prove that using our calculator, the answer is 5. Next, what if our x is 4? So when our x is 4, this will give us 9. So using our calculator again, click calc, and then our value of x, or the value of x rather, is 4, and it will give us 9. And so forth. When f of 1, or when our x is 1, it will give us 6. So from the solution, and as I've said earlier, that the highest is the maximum value, so it is 9. Because 9 is the highest value here, and this serves as our absolute maximum. So you can pause this video and determine what is the absolute minimum. Okay, as you can see in the result, 5 is the lowest, so this is our absolute minimum. So that's very easy in finding for the absolute minimum and maximum using an interval in this function. So let's proceed now to the main topic of this video, which is the application. So question number 1, a cardboard box manufacturer wishes to make open boxes from pieces of cardboard 12 inches square by cutting equal squares from the four corners and turning up the sides. Find, or this problem is asking us to find for the length of the side of a square to be cut out in order to obtain a box of the largest possible volume. So let's take a look with these figures. In figure 4.6.1 here represents a given piece of cardboard, and figure 4.6.2 represents the box. So we now let x be the number of inches in the length of the sides. And then we are going to let V be the number of cubic inches in the volume of the box. As we can see in these figures that the number of inches in the dimension of the box are x, 12 minus 2x, and also 12 minus 2x. The volume of the box, therefore, is the product of the three dimension, and so V is a function of x is equal to x times 12 minus 2x times 12 minus 2x. So by multiplying, we obtain 144x is minus 48x squared plus 4x cubed. So using this equation, if x is equal to 0, we get the value of v as 0, 2. And if this x be 6, the value of our v is also 0. So the interval now is 0 and 6 because v is continuous on a closed interval. So now, let's proceed to our first step, which is what again? What's our first step again? Very good. Which is to find for the derivative of the function, or to get the critical values or numbers. So, what is the derivative of 144x? Very good, it's 144. The derivative of negative 48x squared is negative 96x, wherein we are going to bring down this to here, then multiply it by 48, and then we are going to subtract the exponent into 1. Then the derivative of 4x cubed is 12x squared, because we are going to transfer 3 in this part. So 4 times 3 is 12, and we're just going to subtract the exponent into 1. So therefore, it's 12x squared. So by simplifying, we get 12 times x squared minus 8x plus 12. So again, let's use our calculator in order for us to find for the values of x, or the values of our critical numbers using the original equation. So we are going to set our calculator into mode, and then click 5, and then click 3. Then input 12, then equal sign, then input negative 96, then 144. So we're just following the rule that the one that has the highest exponent must come first. Then, in order for us to find for the values of x, just click equal sign. Then our first value of x is 6. And then the value of our x again is 2. So therefore, the values of x is 6 and 2, and both of them are in the closed interval of 0 and 6. Okay, so in the previous slide, we know our critical numbers or values, which are 2 and 6, that we get it from the equation, and our endpoints 0 and 6, which is in the interval. Then now our second step is to substitute these values into our original equation in order for us to find for the absolute maximum and minimum value. So now let's substitute these values into our equation. So what if the value of x is 2? So using this value. So for 144x minus 48x squared plus 4x cubed, let's change x into 2, and this will give us 128. So to check this or to verify this, let's use our calculator. So 144x minus 48, oops, minus 48 x squared plus 4x cube. Then again, click calc, then input 2 since we're using 2 as the values of x. So 2, and correct. This will give us 128. So what if the value of x is 6? So again, calc 6 and equal sign. So it will give us 0. Very good. So what if the value of our x is 0? And it will give us also 0. So from these values, 128, 0, and 0, what do you think is the absolute minimum? Remember, the absolute minimum is the highest value or highest point in the graph a while ago. Very good. It's 128. And what about our absolute minimum? Very good. Our absolute minimum is 0. You might be thinking or asking yourselves why there are two different places of our absolute minimum. So there's nothing to worry there because we have only one absolute minimum, which is 0. It doesn't matter on how many different places they occur. So Since the problem is asking us for the largest volume, we can conclude that um, the largest volume is 128 inches cube, and this is obtained when the length of the side of the square cut out is 2 inches here. 2 inches. And this is now as our final answer. Sounds easy, right? So for our second example or second problem rather, we have a rectangular field is to be fenced off along the bank of a river and no fence is required along the river. If the material for the fence cost $4 per running foot for the two ends and $6 per running foot for the side parallel to the river, and they are asking us to find for the dimension of the field of the largest possible area that can be enclosed with $1,800 worth of fence. So in here, we are going to let x be the number of feet in the length of an end of the field, and y be the number of feet in the length of the side parallel to the river, and a be the number of square feet in the area of the field. So therefore, based from the problem, the number of the square feet, which is a, must be equal to the product of x and y, which is the number of feet in length of an end of the field multiplied by the number of feet in the length of the side parallel to the river. So therefore, we have A is equal to x times y. So going back to the problem, since the cost of the material for each end is $4 per running foot and the length of an end is x feet, the total cost for the fence for each end is 4x dollars. Similarly, in the cost in the third side, which is 6y. So we have then the equation 4x plus 4x plus 6y is equal to 1,800 because there are two ends there. So we have 4x. And then next in this equation, 4x plus 4x plus 6y is equal to 1,800. We can get its interval because the interval is missing here by letting x and y be the number of 0 or be 0 because both x and y must be non-negative and the value of x that will make a an absolute maximum. So if y is equal to 0, then x would be 225 because 8x plus 0 is equal to 1,800. So 1,800 divided by 8 is 225. And if our x is 0, then our y is 300. So the value of x here will make a an absolute maximum is in the closed interval of 0 and 225 because A is continuous on the closed interval. So therefore our interval is 0 and 225. So now let's express A in terms of a single variable. To do that, we solve first for y in terms of x and substitute the value in the first equation. We have a value which is the a is equal to x times y. So we have this 4x plus 4x plus y is equal to 1,800, and then we are going to add the like terms, which is 4x and 4x would be 8x plus 6y is equal to 1,800. Then transpose the 8x into the other side, which will make it like this. 6y is equal to 1,800 minus 8x. And in order for us to leave y in this part, we are going to divide the both sides into 6 in order for us to cancel 6 inside. So therefore, the resulting equation would be y is equal to 300 minus 4 thirds x. And then by substituting the value of x in our equation, a is equal to x times y, we have it like this. So x times 300 minus 4 thirds x. And by distributive property, we obtain 300x minus 4 third x squared. Okay, next slide. So now let's proceed to the real battle. So using this equation, again, our first step is to find for the critical value of this function by getting its derivative. So what is the derivative of 300x? It's 300. How about the derivative of negative 4 thirds x squared? So transfer 2 in this part and it will become 8 over 3 x because we are going to subtract the exponent by 1. So we have it like this, 300 minus 8 thirds x. So by simplifying this, our x will be 112 and a half. And this will be the value of our critical value. So that's easy, right? So next step is that we know already our critical value and endpoint, which is 112 and a half. And our endpoints are 0 and 125. So as you have noticed that um, we have only one critical value here, and in the previous problem we have two. I think it depends on the equation we are solving or we are finding for x. The one that we solved a while ago is a quadratic equation wherein it has 2x that we solved a while ago, and this equation is, or in this problem, the present equation is a linear function or linear equation rather. So our x is has one only, and this serves as our critical value. So now let's find for the absolute minimum and maximum value by substituting our endpoints, which are 0 and 125, and the critical value of 112 and a half as the value of x. So if our x is 0, it will give us also 0. So next, if our x is 225, you can use your calculator by the way to check whether this is correct or not. So if our x is 225, it will give us also 0. And if our x is 112 and a half, or by substituting this value into this x, says here, so it will give us 16,875. Oh, that's big. So based from this values 0, 0, and 16,875, what do you think is the absolute maximum? So it's pretty easy that the absolute maximum is 16,875 because this is greater than 0. So this now is our absolute maximum, and this 2 here, or this 0 here rather, is our absolute minimum. It's like what I've said a while ago, it doesn't matter if there are two places of the absolute minimum and maximum. So this is our absolute maximum occurring when x is 112 and a half and our y is 150. So where we get 112 and a half? So we get this when we simplified its derivative a while ago. And why, maybe you are asking yourself why where I get 150, and this is obtained in the original equation, which is the 4x plus 4x plus 6y is equal to 1800. When we substitute the value of x as 112 and a half there, here we get 125. So you can check your calculator to verify it. So the problem is asking us to find for the largest possible area that can enclosed in $1,800. So we can therefore conclude that it is a 16,875 square feet is the largest possible area enclosed for the $1,800. And this is obtained when the side parallel to the river is 150 feet long and the ends are each 112 and a half feet long. So for our last example, we have to supplement the income of Russell, he decided to start a business of driving people home from parties. If Russell crammed them, he can fit 20 people in his dad's old construction van. If his profit from driving X people as P of X is equal to X the quantity 10 minus 0.5X minus 20. How many people should Russell load into the van to maximize his profit? So let's rewrite the equation here. And then by simplifying or distributing this x, we obtain 10x minus 0.5x squared minus 20. And to find for the interval, well, the minimum number of people he can have is 0. And 0 serves as the lower bound, right? Because Russell cannot have negative people in the van, so it's 0. And then the problem says that he can fit 20 people, so probably 20 is the upper bound. So we now have the interval 0, 20. So again, right after we get the interval, again, what is our step or first step? Okay, very good. So by getting the critical value through finding the derivative of the original function, and this is the function 10x minus 0.5x squared minus 20. So what is the derivative of 10x? Very good, it's 10. How about the derivative of negative 0.5x squared? Very good. It's 1x or just simply x. So we have p prime of x is equal to 10 minus x. So to equate this, and in order for us to find for the value of x, we have x is equal to 10. So let's just transpose negative x in the other side to obtain 10. And this 10 here serves as our critical value. So now we have our critical value, which is 10, and our endpoints 0 and 20. So the next step is to find the absolute maximum and minimum by substituting these values into the original equation, which is like this. So P of x is equal to 10x minus 0.5x squared minus 20. So if the value of x is 10, we will now have 30. So to verify this, let's use our calculator. So 10x, oh, 10x minus 0.5 x squared minus 20. Then click calc and we are going to write the value of x, which is 10, then equal sign. So that's it. It's 30. So how about the value of x is 0? So let's substitute 0 from this equation and this will give us negative 20. So you can check your calculator to verify the answer. So what if the x or the value of x is 20? So we're going to change this 20 and 20. So this will give us negative 20 as well. So what do you think is the absolute maximum here? Very good. It's 30, which is higher in 10. So, but the question is asking how many people should Russell load into the car to maximum his profit. So the answer here would be 10 people because it has the highest absolute maximum rather. So the number of people that he can load into his dad's car is 10 people. So to end this, you might be asking, how do you find the critical value of an interval? So to find this or to find the critical points, you must first take the derivatives of the function. Second, set that derivative equal to 0 and solve for x. So each x value you find is known as the critical number. Third is plug its critical number into the original equation to obtain your y values. So next is that, are the critical points always extrema? So a critical point on f of x occurs at x sub 0 if and only if either f prime x sub 0 is 0 or the derivative doesn't exist. Occurrence of local extrema. All local extrema occurs at critical points, but not all critical points occur at the local extrema. So that would be all, and that ends my presentation. Thank you for listening, and I hope you learned a lot. Let us continue learning in this new normal. So muchas gracias, mi amigos. Caritas Christi Urgetnos.